Yeah. Okay. So we're starting on page 3. I'm avoiding pages 1 and 2 because they will be where 100% of your stress and confusion lies. I didn't want to, I hadn't seen you in 6 days. And I thought, well, how could I come back and then make you miserable right away? So I didn't want to. So we're going to start on page 3. Um, Today I'm introducing you to some new words. And for this, I almost feel like I need a new page. Am I recording? Did I hit resume? Yeah, I did. So I'm going to make a new page and just explain something to you that from this point going forward, you're going to be seeing these words a lot. You really want to not be whispering to your neighbors during today, or you're going to get very confused. So you're going to see these words, and they're not big words. They just mean a lot in mathematics. And so, have you guys ever heard these words before? Maybe I never know what Mr. Manlove did over there. We worked together, but I don't know what he did across the hall. Have you ever heard this before? Ring a bell?
Yeah, but not the main.
And it's funny that the range is one that you've heard and it's funny because it kind of means something different in algebra than it did. Your previous understanding of range would have been like if I put a list of numbers, you would have taken like the biggest one minus the smallest one, right? Does that ring a bell? Right. And so that's not really the same thing, but I hear that a lot. So the domain is the set of inputs. And generally, I will say this, uh, a true mathematician purist would probably have me incarcerated for this, but generally it's your x's. So for our purposes here for the next few days, you need to know that the domain is the set of x's. And then the range, you probably already know where I'm headed with this. What do you think the range is? The set of what? The outputs. Every single mathematical relation, whether it's a function or not, is a set of inputs and outputs. Inputs get fed in, outputs they come out, right? And so the set of outputs is your range, and those would, of course, for our purposes, be all of the y's. So the x's will be your domain, and the y's will be your range. Now I'm going to show you today. This is going to be just like last hour. I'm just hitting people hard today with this. This will be a long lecture today, so settle in here. You're going to see two types of domains and ranges. And so the reason I'm starting on page 3 with problem 13 in your notes is because these are not connected points. If you were to flip back to the first page of your notes packet, you don't have to, but if you were to look back at them, they look like this. And you'll notice that that's not just a set of individual points, is it? This is what we call continuous. Continuous meaning the points are all connected, meaning like number 1, how many points are there in problem 1 on the blue graph?
One.
Nope. Nope. Try again. The bigger, 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 bigger than 18, bigger than 624 trillion. Keep going. There are infinitely many points on problem 1. If you think about it, when someone connects, Mr. Manlove probably said something to this effect, I'm guessing at some point, maybe in your time with him, that even if you draw a line segment that's only like 3 inches long, there are infinitely many points on that line. Imagine you had the world's most powerful microscope and you zoomed in on that line and you're like, I'm going to get as close as I can. You're never ever going to see a space between 2 points. No matter how close you get, every point and another point has a point between them. And then those 2 points have a point between them. It's this idea of continuity. You could draw a line segment that's a quarter of an inch long, and it would have infinitely many points on it. Which means if I said to you, list all of the points in problem 1, you cannot do it using conventional set notation. You couldn't do it saying, well, okay, here it goes. I'm going to list this, 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 and this. You couldn't do it in a million human lifetimes. However, in problem 13, how many X's do you see?
Four.
I see 4. I see 4. And their names are -4, 0, 1, and 3. We can all agree that there are quite literally 4 X values in that table, right? How many Y values do you see? I see 5. These numbers, I'm going to use these words. I didn't used to use these words, and then I decided ninth graders deserve this. You need to know the difference. Starting on problem 13, we are going to be dealing with what's called discrete points. Discrete meaning I can place my finger on each one and say, I see you, I see you, I see you, I see you, and I see you. Whereas on problem 1, I cannot acknowledge every point on that curve. Therefore, in problems 1 through, I think, 12, you will be working with what's called continuous points. So continuous means there's so many of them and they're connected that I can't list them all out by hand. Discrete means I can see each one of you. That's a very upper level mathy sort of thing. Continuous, flowing, connected, discrete, boop, 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 like I can pinpoint every one of you. Does that make sense? Okay. So again, I'm starting you on page 3 because once we learn how to do domain and range on this, this will go quick. This is actually really, really simple stuff. So the domain I just told you a little while ago is the set of all of the X's. And so here's how you're going to write the domain. You're going to write a capital D, and then you're going to write like a colon or an equal sign would be fine. And then you're going to practice a skill today with me. You're going to draw one of those. And I will say it is not something that you're born with the ability to do, to make a curly bracket, but you must use a curly bracket when listing discrete domains and ranges. This in mathematics is what we call set notation. I'm going to go to my other page and make a bigger one so you can see, and you're going to practice this skill. To make a curly bracket, it goes like this and then like this. It's the same pattern repeated. That is the best curly bracket I've ever seen, Cooper. That just gave me goosebumps. So you're going to have a curly bracket this way and a curly bracket this way. This is not optional. Okay, that is how you denote a discrete set of numbers. So going back to the, and you'll practice this a lot as we go, don't worry. So going back to my other page, to list the domain, what I'm going to do is I'm going to list each member of the X family in order, one time only, from smallest to biggest. Who's my smallest domain member? So I'm going to write -4, comma. Who's second smallest? 0. Next. 1. Next. 3. Note that we do not have repetition when we list a domain. Okay, the domain does not want repetition. Our domain members are those 4 guys. And now we're going to write the range, capital R, curly bracket. Who's the smallest member of my range? -7. We do not try to correspond domain and range elements. I don't care who goes with who. This isn't up to us. We will always list our elements from smallest to biggest, regardless of what order they come in the problem or in the data. Who's after -7? After that? After that? 0, and after that? 5. That is how you write out a discrete domain and range. Capital D, capital R, curly brackets, elements separated by commas, small to big. And I have to do the other part of this, by the way. It says to determine, right here, I'll underline it in purple. Every problem in this packet is going to say determine if it's a function. I'm never going to stop asking you this question. And Joseph had it right away. Is number 13 a function? No, so we can just write like not a function. Just write not. That's fine. And we know it's not a function from what we know from last week, that because the input of 1 going to multiple outputs, and that's why this would not be a function. All right, let's practice again on problem 14. Well, we can get this out of the way right now. Is number 14 a function? Yeah, so I would just write function. There's other ways to communicate that. Doesn't matter. Just know that that's what we're saying that for us. Because yeah, this one's a function. And so here we go. The domain is, what's the smallest member of my domain? Next, 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 next. Good. Range, smallest, next smallest, next smallest, next, next. Good. Let's do another one. Bless you. Number 15. Is he a function? No. So we're just going to write not. Domain. Who's smallest domain guy? Next, next, next. Nice. Is it true that if a relation has less elements in the domain than the range, that it cannot be a function? That has to be true, doesn't it? Because if you have only 4 elements in your domain and 5 in your range, you cannot escape the fact that someone in the domain has to do double duty, right? There's one worker that has to do 2 jobs. So that's a pretty take it to the bank kind of thought. If I see a smaller, we don't see it uh, until we write out our domain and range, but that's the idea. What's the range? Who's my first range guy? Next, 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 next. Good. Nobody. Thank you for your silence. Yes. Remember, there are 2 6s, but we only want to list it once. No repetition. All right. You ready to head on to, you can finish that at your leisure whenever. Let's head on to 17 through 20. Same idea, right? And we'll probably just do a couple of these together. On 17, same idea, domain, range, curly bracket. I didn't leave enough space here. I wish I had this to do again. I would have left you more room. Apologies. What's the first domain element on number 13? -5. Next, next, next. Right. And you'll notice that the computer, when it generates these, it always puts the points in order from domain small to big. But then the range is kind of like not up to anybody. It just happens. Who's my smallest range guy? -5. And it's just quite literally translated, it's the smallest y coordinate I see, right? Who's after -5? There is a 0 after 0. There is a 1 after that. 5 after that. Good. Is this a function? And we know just because there's 4 elements in the domain and 5 in the range, it's literally impossible for it to be a function. One of those 4 numbers in the top has to do 2 jobs to cover the ones on the bottom, right? So in this one, we would just write not a function. Do you have any questions about that section? Okay. Again, you feel free to fill the rest of those in at your leisure. I don't think I need to spend any more time. Let's head down to the next section, which is graphs. Bless you. And I'm going to zoom in a little bit on this one, just so that everyone, you can see it on your paper, but I just wanted to have a good look here. So this time it's coming at you a little bit differently. Let's start with domain, D, colon, curly bracket. What's the lowest x coordinate you see on this graph? Thank you. Yes, -3. We know that with ordered pairs like this, points, that the x's are the sideways coordinates. And this point that I'm circling right here is the furthest to the left. So his domain element ought to come first. So -3 is our first domain element. -3 is not a domain. -3 is a domain element. Who's after that? 0 is the next x I encounter. Who's after that? Who's after that? Correct. So my domain has 4 elements. Range, I will change the way I think now. I will not think left to right. I will think low to high, correct? Who's the lowest point? Well, it just happens that it's the same one. Coincidence. And his y-ness is down 5. Work your way up now, upwards. Who's the next -2. Who's after that? Who's after that? Nope.
0.
0. There's a point at a height of 0, and then there's another point at a height of 5. And again, you can now you're smart enough and experienced enough now to answer this question one of two ways. Is this a function? No. And you could answer it by saying it fails the vertical line test. So if I take this vertical line and I put it in here and I scan it across, can you see how it pings these 2 points right here? So you could answer the question intelligently as saying it's not a function because it fails the vertical line test. Or if you didn't know the vertical line test, you could explain it away as there's 4 elements in the domain and 5 in the range. There has to be one of the x's doing double duty, right? Let's go again. I think I'm more interested in question 23. Would you guys flip to the back page? I hear sometimes that people are concerned with these 2 points. Are we? Why not?
They don't align.
I could not have chosen very much better words than that. They don't align vertically. They can align horizontally, as we discussed, and that's fine. But vertical alignment is where functions become non-functions, where relations become non-functions. So good. That's why I wanted to pick this problem in particular. So, by the way, going back to number 21, was that a function? No, right. So I don't know if I ever wrote it, but we would write like not or not a function or no or something like that. So on question 23, let's get started. What's our first domain element? -7 is the furthest amount of leftness we ever obtain. After -7, after -3, -2, after -2, after 2, 3. Are you feeling that vibe, the flow of left to rightness? I hope so, because that's the only way the last part of this lesson is going to make sense. The hard part be the first 2 pages. So domain is a vibe, like a flow of left to right. Range, I teach myself, is a flow or a vibe from low to high. Who's the lowest y-ness in this graph? -7. Next, -6. Next, next, 4. And you guys are pretty good about not saying the same number twice. These 2 numbers or points that I just circled in red, they share a range element, and that's okay. 2 different domain elements can be associated with the same range element, and that's fine. Do you have any questions about that section? And this last section will almost insult your intelligence, so I apologize in advance. But to prepare you for things like Y-top and other stuff, I just want to make sure that we do our due diligence and cover all of the different bases. So this one is kind of a joke. I mean, look, like, hello, they're already labeled for us, right? And so, but we are still going to do what we do. I want you to practice with your notation, your curly brackets, all that stuff. So the domain in order should go -3, 3, 4, 5. Any issues with that? And the range, generally you're going to find with these that they're already placed in order. That's what's kind of special about a mapping diagram, is that whoever made the mapping diagram is generally going to control it and already have the domains from small to big and the range from small to big. It's pretty unique to be able to do that. And then, of course, the range is in order already: -5, -4, 0, 3, 6. Is number 25 a function? No. My answer this time would be, one of 2 things. If you're a visual person, your explanation would be, I can see divergence from -3. Remember, it's divergence that causes that. And if you're not a visual person, you could make a case that, well, the domain only has 4 and the range has 5. So that's impossible. Do you have any questions about any of that stuff? Because I want to now spend the rest of our time on pages 1 and 2. These are the poopy ones. Do you need a quick break before we transition back? Do you want a couple minutes, or are you good? We're good? Okay. Head back then to the beginning of the packet. There's no way around the fact that this is just a struggle. So you're going to learn today about what we call an interval. And interval notation is something you'll use forever, depending on some of you are going to take 8 or 9 or 10 more math classes after this. Some of you go into college and decide to do anything that involves mathematics, sciencey, engineering. Math will always expect you to know how to do intervals. And so here we go. I cannot express my domain in problem number 1, and I don't take that lightly. I cannot express my domain like this, because the moment I put that curly bracket there, I tell someone, hey, I'm going to list for you a set of numbers. And I don't have enough human lifetimes at my disposal to sit here and write down every x coordinate that is on a blue point on this graph. Therefore, I cannot use a curly bracket for number 1. I must use a different notation, and it's going to go like this. You're going to put a square bracket, and I'll explain to you why that's square here in just a moment. And now I'm going to ask you a question. How far to the left is the leftmost xness on this particular blue graph? -5 is the furthest leftness that this graph ever obtained. So I'm going to put -5, comma. What is the furthest right? And by the way, I will tell you before I ask this question that the answer is not 3. What is the furthest amount of rightness that this graph ever obtains? What did you say? Correct. Exactly.
It's infinite.
Having said that, nice job. Right here, there's an arrow, and you can see it on your paper. I just sort of accentuated it there on my television. That means that this graph is never going to stop doing what it's doing. This continuous graph is going to start here where I'm kind of moving my pen, and it's going to go, and it's going to go forever. In math, there's a number or a word that we use to designate foreverness. Do you know what it is? It's called infinity. Yes. And so, having said that, I need to tell someone that this graph, horizontally speaking, goes from a leftness of -5 to a rightness of infinity. And I will have you put a round bracket, also known as a parenthesis, around the right-hand side. I will explain more about the difference between the square and the round brackets in question 2. But for now, that is what an interval looks like. You just now saved yourself an infinite number of human lifetimes by, instead of trying to list every x coordinate from -5 to positive infinity, you expressed it as an interval, saying it starts here and it goes here, and everything in between is included. Let's go again with problem number. By the way, is number 1 a function? No, absolutely not. It fails the vertical line test miserably. Let's take a look at problem 2. Oh, but I didn't do the range. I'm so sorry for that. Geez, what a slacker. We're not ready for problem 2. We have to do the range. And the idea is still what it always has been, and that is what's the lowest y-ness that this graph ever achieves? How low does this graph go? To -7. You are going to use a round bracket and put -7. And how far up does this graph go? To infinity and beyond. And you're going to put a round bracket on that. With interval notation, you will always either use a square bracket or a round bracket. Has anyone figured out yet the difference between square and round, like when you might use one? It's vexing until you know the secret. You'll know the secret after we do problem 2. You will. If you're paying attention, you will know. You'll figure this out. I won't even have to tell you. In question number 2, for the domain, what's the most leftness this graph ever achieves? I'm going to put a square bracket, bless you, and put -6, comma. What is the furthest rightness that this graph ever achieves? I am going to put a round bracket. Did anyone crack my code? It has something to do with the dots, yes. What do you think a filled in dot means over here where this arrow is pointing? It can be there. It can hit that. It can land on that point. That point is included. What do you think the hollow dot means? It's not included. This is called inclusive. The other one, the opposite of inclusive, is exclusive. So there it is. Thank you for your help with that, Jess. The difference between a colored in dot and a non-colored in dot is the difference between a round bracket and a square bracket. We use square for inclusive. We use round for exclusive, which begs this question. All right, wise guy, Mr. Ahern, why did you use an exclusive bracket for your infinities? Yeah, you can't, because you can't get there. Can you ever make it to infinity? No. That's why infinities always get round. Always. Let's go again. Range. What is the lowest amount of lowness this graph ever achieves? Does it get to -2? Yes, it does, because there's a colored in dot at a lowness of -2. What's the highest this graph ever achieves?
0.
It is 0. Does it make it to 0? Yes, it does. I would expect, don't worry about how cold it is in here, just worry about your learning, okay? We're all in the same room. So you can see right here that this is the highest point. I'm kind of putting a hat on it, right? You can see, and it does get there. It hits and bounces, so we assume that it gets there. That's why it got a square bracket. Let's go again. And did we already answer? Is that one a function? Yeah, so you could just put function or yes or something like that. On number 3, we're good now. Here we go. We got the hard part. The awkward introduction is out of the way. I know. All right. So the question is, how far to the left does this graph go? So we do not put infinity. Did you say negative infinity? The answer is yes. You're on a real roll today. The answer is that the graph, as far as how left does it go, is it makes it to negative infinity. You have to put a negative on your infinity signs when they're to the left. How far to the right does this graph go? To positive infinity. And those will both be round brackets, aka parentheses. Let's talk range. What's the lowest amount of lowness? This is it right here. You would agree if I put a bottom on that, like that base shows the bottom, right? How base is that? Does it get to -1? Therefore, I square bracket my -1. And how high does it go? Infinity. And you do not need to put a positive sign on an infinity. The absence of a sign is an implication of a positive sign. It always has been that way. 2 + 2, we don't write like +4, right? So you only need signs if it's a negative. And that is our domain and our range. Is number 3 a function? Yes, it is. Let's look at number 4. Domain. Listen, you're going to walk out of this room today in one of two states. You're either going to completely understand this or you're going to completely not. There's not a lot of middle ground with domain and range. I need to keep using the same words so that you use these same words. Don't make this too hard. Here it goes. How far left does the graph reach? How far right does the graph reach? If you can answer those questions, you understand domain. What's the leftiest leftness of this graph? It's right here. It's at -5. And I know it looks a little. So the domain goes from square or round? Square, because it makes it. I see it getting over there to -5. And how far right does it go? To +7. Does it make it? Then I square it. With everything, and whenever you see these ellipses or circles, these eggy looking problems, you're always going to have squares, quite frankly, because it gets to its edges. What's the range? Always low to high. Always low to high. Good job. -3 is the lowest. Never do your domains and ranges high to low or right to left. Never, ever, 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 ever. We're always small to big. -3 is his lowest low. What's his highest high? Nice. And he makes it. Is he a function? No. No way. It's total non-function. Let's look at number 5. Number 5. What an interesting looking situation this is. For the domain, um, again, I have to ask myself, hey, Graphy, how far left do you go? What's his leftiest leftness? -7. Does he make it? Then I shall square that off. -7 squared. Remember, that's called an inclusive bracket. How far righty does he go? Does he make it? We can tell from those colored in circles that it actually gets to those points. For the range, what's his lowest lowness? -7. You can see that his bottom is down here. I put a little base on it for you, right? So -7 is his lowest low. What's his highest high? What an it's +7, right? You can see he caps out up here. And what an interestingly like symmetric answer. Is he a function? Why not? Right. Listen, if I make a vertical line and then I grab hold of it and move it, can you guys see how this section of the graph right here fails the vertical line test? So this is not a function. It would pass everywhere else, like over here, everything's fine, but this one section is the wrecker. So we would say, nope, you're not a function here. How about number 6? I wish my thing didn't have these weird visuals. I'm sorry for that. I wonder if I zoom out and zoom back in, if I can. Oh, that's better. Fixed it. I bet if I move it, oh, gosh, little dog. Okay, good. Now I know how to fix it. What's the domain? How far to the left does Graphy go? Does he make it? So what do I use? An exclusive round bracket. So we say that the domain starts at -4, but we put the little caveat in there that it doesn't really make it. How far to the right does he go? To infinity and beyond. Infinities are always round brackets. For the range, how low does homie go? Does he make it? You can see that at this lowness, this red point, he does not actually get there. So we state -4 is the beginning of the range, again with the caveat that it doesn't really ever get there. How high does it go? Infinity. Good. Get a lot of questions about problems 7 and 9. Let's take a look at these. In question number 7, what's the domain? How far left does Graphy go? How far right? That's -3. And how far right does Graphy go? I know you're probably 3/4 asleep by this point in this lesson, but I need you to wake up for this. You can and are expected to not use interval notation for this. You will use set notation. How many elements of the domain are there in this graph? 1. So I say the domain is a set of numbers that contains only the number -3. I use set notation when I can. I use interval notation when I can't. You see that? What a neat, unique situation that is. And as far as the range is concerned, how far low does Graphy go? To -infinity. He's like, I'm going forever downwards, baby. How far up does he go? +infinity. So remember, your negatives are reserved for lefties, downies. Your positives are reserved for righties, uppies. Having said that, I'm going to skip ahead to problem 9, and this will conclude our time together. So please stay with me for problem 9, and then I'll get you packed up. In problem 9, what is the domain? In other words, how far left does Graphy go? To -infinity with a round bracket. How far right does Graphy go? +infinity, round bracket. And just like the problem before, I wanted to make sure to get your eyes on this. What is the range? And I will use a set notation for this to say that it is only one range element and his name is 5. I'm going to say this on the recording. What I would like you to do in the next 23 hours and 15 minutes is, if you want, you don't have to finish this packet. I think we've covered everything today through some miracle. Tomorrow I will hand out the assignment. If you know you're going to be gone tomorrow, please get the next assignment from me right now. Otherwise, I'll just hold on to them and give them to you tomorrow. Got it? Okay. Yeah, get packed up.
Sure.
Uh-huh.